Today you will identify correlation squared and find residuals. So R squared is the percent of variation accounted for by the model. Remember, because it is a percent, it is always between 0 and 100%, and the higher the percent, the better fit your line. So if we look at the two pictures, the picture on the left has a stronger R squared because there are more points closer to the line than on the picture on the right. So a residual. Well, a residual is the difference between the actual y value and the predicted y value. Notice we have this formula, r equals y minus the y hat value. And it just simply indicates how far off the model is at a specific point. So notice that we have this point y, and its residual is on the regression line. Well, this vertical distance is what is known as the residual. And all of the residuals will sum to 0. So a residual plot, the things to remember, the x-axis is the same as the explanatory variable, but the y-axis is now the residual axis. When a set of data has a linear pattern, its residual plot will have a random pattern. If a set of data does not have a linear pattern, its residual plot will not be random, meaning there will be a pattern. So these are different residual plots that we might see. So this top residual plot, the regression line fits well because the residual plot has no distinct pattern. However, the residual plot below, the data is curved, so therefore the regression model fits poorly. And if we look at this residual plot, it starts to kind of fan out. And so it starts off pretty accurate, but as x increases, obviously our prediction becomes less and less accurate. So if we look at the next example, the first thing we're going to do is we're going to draw a scatter plot. So here is the scatter plot you should have drawn. The next thing you'll do is you'll find the linear regression model, the correlation, and the correlation squared. So remember, we do this on Desmos or in a calculator. Do it now. Hopefully you found your model to be y hat equals 1.4x plus 2, the correlation to be about 0.89, and the correlation squared to be about 0.79. And then the next question, how does the linear regression fit the data? Well, we could say 79% of the variation is accounted for by the model, or we could say it's moderately strong. So next, we're going to complete a residual table, and you will actually be doing this on your second formative. The first thing we need to do is we need to find all of our predicted values. So remember, to find this predicted value for x is 0, remember we're using our model y hat equals 1.4x plus 2. And I'm going to replace the x with 0 and figure out the y. I'm actually going to do that for all of the original x values. Do it now. So if we look at all of our predicted y values, you should have found something similar to these numbers here. Now we're going to find our residual values. So what we're thinking about for these residual values for this first blank, we are thinking in our minds, I'm going to take the y minus the y hat. So 2 minus 2, well, that equals 0. If we look at the next one, we're going to take 5 minus 3.4. Okay, so 5 minus 3.4 is 1.6. Okay, so continue down the rest of the column. So hopefully you find the remaining residuals to be negative 0.8, negative 2.2, 0.4, and 1. So notice at the bottom of the table we have the sum of the residuals. So we're going to take this column and add those values together. So hopefully you find this is 0. And now all we're going to do is we're going to graph. Remember, you're going to use your original x values with the residual values. So for example, I'm going to graph 0, 0. Oh, no, that's not 0. Yes, it is. 0, 0. Next point is 1, 1.6. The next point is 2 and negative 0.8. The next one is 3, negative 2.2. 4 and 0.4. And 5 and 1. So if we look at our residual plot, what do you notice about it? Well, hopefully you recognize that there is no distinct pattern with the residual plot, therefore the model is a good fit. Let's look at another example. The first thing we're going to do is we're going to sketch the scatter plot. So if we look at the question, it says, does the data appear to be linear? Obviously, it looks more exponential in shape, so we are going to say no. And just like we did with the previous example, we need to find the linear regression, the correlation, and the correlation squared using a calculator or Desmos. Do it now. So hopefully you found your linear regression equation to be y hat equals 1.44x plus 1.91. The r value is about 0.91 and the r squared is about 0.82. And how does the linear regression fit the data? Well, hopefully you say not well. It's a curved relationship. So notice we're going to do the same exact thing that we did on the previous example. So remember to find our predicted y values. We're thinking in our brains our regression model we found. Remember it was y hat equals 1.44x plus 1.91. And to find this first prediction, remember we're going to take our x value, negative 2, and replace the x in the model. And when you use a calculator, you should get something around negative 0.96. Take a minute or two and fill in the rest of the predicted y values. And remember to find your residuals, you will take your observed values minus the predicted values. So in other words, you're going to subtract these two values. When you do so, you should get 1.21. Take a minute and try to find the rest of the residuals. So hopefully you found the following residual values. Now remember we have this column that says the sum of the residuals. All you're going to do is take those residual values and add those together, and they should give you 0. Now remember, next thing we'll do is we'll take our original x values and we will graph with its residual values. So the first point that we will graph is negative 2 and 1.21. Negative 1 and 0.03. 0 and negative 0.91. 1 and negative 1.34. 2 and negative 0.78. And 3, 1.79. So what do we notice about this residual plot? Well, hopefully you recognize that there is a definite pattern. And you can summarize your observations about residual plots. Remember, if the residual plot has a distinct pattern, the regression model does not fit well. If there is no pattern, meaning it's random scattering all over the place, then we say the regression model is a good fit.